Hi, this is Mr. Ariel, and I'm here today with a little practice on bonding basics. Make sure you have a periodic table nearby, and let's go ahead and get started. So for the first part of the practice, we just need to go to the periodic table, and for chlorine, we need to find the atomic symbol, and that would be C lowercase l. I always write it kind of cursive, otherwise it looks like C with a 1, or a capital I, and that would be incorrect. So the total number of electrons, if you look at chlorine on the periodic table, its atomic number is 17. And so it's got 17 electrons. Now chlorine is also in group 17. And if you remember the trick that we look at the ones digit of the group number, that'll tell you the number of valence electrons. And so group 17, that ones digit is a 7, and so it has 7 valence electrons. Now for this number of electrons gained or lost, remember that all atoms need a stable octet. And so that means chlorine could gain 1 electron, or it could lose 7 valence electrons, and that next energy level below it would then be the outermost, and it would be full. Just remember that all atoms will always gain or lose the smallest number of electrons possible. And so chlorine here would simply gain 1 valence electron. Now for this last part, oxidation number, that may not have shown up in the notes just yet, so make a note on this paper that oxidation number is the charge formed by an atom when it becomes an ion. So if chlorine gains 1 electron, that's simply going to be 1 minus, or -1 as a charge. Now I want you to try these next 2 rows on the table just for practice, and we'll check those answers, and then after that, you'll be able to try all the ones below it. So go ahead and pause the video. Alright, so here are the answers for potassium and magnesium. Go ahead and check your answers real quick, and if you have something that you're confused about, be sure to ask me in class. And when you're done checking, go ahead and try the next problem, starting with fluorine and moving down to iodine. Alright, here are all the answers to the rest of the problems. Before you pause the video, I do want to point out this element right here. Carbon has 4 valence electrons. And so it can technically gain or lose 4, and that would mean it has a charge of 4 minus or 4 plus. But I just want to tell you that you'll never have to figure out which one it would do. That's kind of outside the scope of this course. So pause the video, check all your answers, and if you got anything wrong and you're confused about it, be sure to ask me about it in class. I'm happy to help. Now moving on with the practice, we have a couple of review questions. This one says an atom that gains 1 or more electrons will have a blank charge. So I think that's going to be negative because electrons have a negative charge. And if we had 10 protons and we had 11 electrons, that would work out to be -1 as a charge. Now an atom that loses 1 or more electrons will have a blank charge. That's going to be positive. In other words, the atom would have more protons than it does electrons, and so that's an overall positive. Now, an atom that gains or loses 1 or more electrons is called a blank, and that's kind of a new vocabulary word for us. That's an ion. And the last one says a positive ion is called a blank, and a negative ion is called a blank. Well, both of those words end with ion. And remember in the notes, I taught you to think about positive ions as being positive, and that can help you remember that this is a cation. And then the negative ion, I taught you a way to remember that anion sort of stands for a negative ion. And so that's anion for the last answer. Let's move on to the next part. We got some more fill in the blanks. Atoms will transfer 1 or more blank to another to form a bond. And this is an ionic bond. I should have mentioned that. And so this is where we transfer electrons. And then each atom is left with a blank outer shell. And so that's going to be a full outer shell. Maybe make a note here that this is called a stable octet. Usually that means 8 electrons. Now for the last question, an ionic bond forms between a blank ion with a positive charge, and so that's going to be cation, and a blank ion with a negative charge, so that's going to be anion. Alright, now the next part is just some examples, and I didn't really show you how to do this in the notes. We're just going to draw out ionic bonds. Now sodium is in group 1 on the periodic table, and so it has 1 valence electron, and that's what we need to do is draw an electron dot diagram for each element. And then chlorine, that's in group 17, and so it's got 7 valence electrons, so I'm going to draw those in. And now to make the bond, this 1 electron is going to move into that spot. So I'm going to redraw that. That's going to be sodium, and it's going to be +1, and this will be chlorine, and it's got its 7 valence electrons, plus the one it got from sodium. I'm still coloring it in black. And now this chlorine would be -1. Now the last step, we just write out the formula, because that's the finished form of sodium chloride. Now one side note here, if you're wondering why I wrote 1- instead of -1, and over here I wrote 1+ instead of +1, the reason for that is there's a different notation in chemistry where we would write +1 and -1, and it gets confusing if we write it in that same form right now. All right, so let's get one more example right here. I'm going to set up magnesium and iodine. So magnesium, that's in group 2 on the periodic table, and so it's got 2 valence electrons. And then I'm going to put in iodine, and that's from group 17, so it's got 7 valence electrons. Now, just like last time, we can take one of those valence electrons and put it right here on iodine, but that is going to leave us with an extra valence electron on magnesium. Iodine won't be able to take more than 1, because once it's got 7 plus an extra, that's a stable octet. And so what we're going to need to do here is bring in another iodine, and it's got 7 valence electrons. And so that extra electron is then going to go on to the second atom of iodine. Let me rewrite this one more time. That'd be iodine with its 7 valence electrons. I'm going to go ahead and draw the other one just to stay in red for a minute. And then each of the iodines would have gained 1 electron from magnesium, and there's magnesium. And we draw magnesium with no valence electrons, but truthfully, it does still have electrons. Let me draw them all out. It's got 12 to start with. So there's the first 2, there's the next 8, and here are those 2 valence electrons that we started with. And so when magnesium loses those 2 valence electrons, it forms a stable octet because the next energy level below is now full, and it's the outermost level now. But we simply don't draw any of that on magnesium. We leave it kind of blank. But that would give it a 2+ charge, and then each of the iodines would be 1-. And so to finish that up, we just write out the formula that it's Mg, a single magnesium, with 2 iodines, and so I'll put a subscript 2. Now if you flip over the page, you're going to find 4 more practice problems up at the top, so go ahead and give those a try, and then come back and check your answers. All right, there's the rest of the answers for these 4 problems. Be sure to check all your answers, correct them if needed, and if you have something on your paper that you're confused about what you did, be sure to ask me in class. I'm happy to help. When you're done checking answers, let's move on. All right, on section C, we have a couple more questions to answer. Atoms blank 1 or more electrons with each other to form the bond, and this is a covalent bond. And so that's where atoms share 1 or more electrons with each other. And each atom is left with a blank outer shell. That's going to be full. Or remember, another way to say that is a stable octet. And last, a covalent bond forms between 2 blanks. And that's the type of atom we're talking about. And that's always 2 nonmetals. All right, so we have some examples. And what I'm going to do here is going to be a little bit like what I did in the notes, but kind of different, but I think you'll get it. We've got 2 atoms of hydrogen, so I'm going to draw out each one with its valence electron. So here's hydrogen over here, and it has a valence electron as well. Now to show the covalent bond, what I'm going to do is draw the electron cloud of the left-hand side hydrogen, but it's going to once in a while include that right-hand side valence electron. Now remember that that 1s energy level can only hold 2 electrons, and so when each atom has a 1s2 configuration, that's the same configuration as helium, and so it's not a stable octet, but it's a full outer shell, so it does the same thing. Now to finish up this drawing, I'm going to draw the electron cloud of the right-hand side oxygen, just like this. And so that's also got 2 valence electrons now. Now the last 2 steps are draw out the bond. Instead of drawing the dots, we're going to draw the bond as a single line representing 2 electrons. And then we write out the formula that that's H2. And that's the final answer. All right, so I'm going to do one more here just for practice, and then I'm going to turn you loose to try the next 4 on the paper. So for this one, we've got 2 hydrogens. So I'm going to draw in a hydrogen. And then I've got a hydrogen, I'll just put it over here. And we have a single oxygen. So that's going to be right here. And oxygen's in group 16. It's got 6 valence electrons. And so we'll draw it just like this. To draw in those electron clouds, the hydrogen on the left would once in a while include that extra electron from oxygen. We can do the same thing over here. And then oxygen's electron cloud would include the 6 around oxygen. And once in a while it would take hydrogen's electron and this one over here. And so if you're losing sight of the goal here, remember each atom needs a stable octet, or hydrogen really just needs 2. And so if I count them up, this oxygen would have 1, 2, 3, 4, 5, 6, 7, and then there's its 8th electron for a stable octet. Let me take those little marks back out. All right, now to finish this up, we would draw in the bonds as a single line to show 2 electrons. And then the last step is we need to draw those unshared electrons. I mean, there's 4 of them on oxygen that aren't shared with hydrogen. And so then we finish it up by writing out the formula that we have 2 hydrogens for every oxygen. And that's the final answer. Now I want you to try this 3rd and 4th practice problem and then come back and check your answers, and then we'll do the last 2. All right, there are the answers for those next 2 problems. Check your work, and if there's something confusing you, be sure to ask me in class. I'm happy to help. When you've got those done, go ahead and try the last 2 problems on the paper and come back and check your answers. All right, so there's the answers to the last 2 problems. Check all your work, and again, if you missed something, if you're confused about it, whatever, just ask me in class. I'm happy to help. But if everything's all good, this is the end of the video. I hope it's been helpful to you today, and as always, thanks for watching.